Hello, in this video I want to talk about derivatives, about differential calculus, and then to briefly give you a graphically as well as a mathematical intuition or introduction to what is happening when we take a derivative.
You are watching a Bankademy video.
Imagine we have a linear function f of x equals 2x, then the derivative in respect to x is 2. So how can we show that graphically? Let's draw the graph. So here we have the y-axis and here the x-axis, and we have 1, 2, 3, 4. So and here 1, 2, 3, 4, and our function would look like this. So at point 1 we are here, at point 2 we are here, and our function looks like this. So here we have the point, let's say x1, y1, which is 1 and 2, and here we have the point x2 and y2, which is 2 and 4. Now we can draw this triangle. We go 1 to the right and 2 up, so this is 2, and we have a slope of 2. We can also calculate the slope, m, the following way. So m equals delta y divided by delta x, and what is delta y is y2 minus y1 divided by x2 minus x1. So in our case we have y2 given as 4 minus y1, which is 2, divided by x2, which is 2 minus 1. And so we see 2 divided by 1, which is 2, so we have a slope of 2. So this function has a slope of 2 for the whole range, as it is linear. But when we now look at the function where we do not have a straight line, we face some problems. Let's look at the function f of x equals x squared divided by 10. So the derivative of this function would be 2x divided by 10, which is x over 5. How does this function look like? You can draw it like this. Here we have the y-axis and here we have the x-axis. So here is y and here is x. And so we have then these points here and here. So let's see, this is 5, 10, 15, 20, 25 and 50. And here we have a bit of a different scale. So here we have 10, 20, 30, 40, 50 and so on. When we are at the point 5, it's x squared, which is 25 divided by 10, so we end up at 2.5. At 10 we have 10 times 10, which is 100 divided by 10, so we are at 10 for the y value. And if x equals 20, we have 400 divided by 10, giving us a value of 40. So our function looks like this. So let's say we're interested at the slope of the tangent line at point x equals 10. So trying to find out what slope a tangent line at this point would have, we can try to do this step as before. Look at this point, and then draw this line here and see what slope it has. This would mean here we have x1, and then we have like x1 plus h, and here we have, let's say, y1, and then y1 plus g. As before, m equals delta y divided by delta x, which is in our case 40 minus 10 divided by 20 minus 10, which would give us 30 over 10, which is 3. So if we plug the 10 in here, we see that the derivative at point 10 is 10 over 5, which is 2. So we see this is not the same. So let's try it with a different interval. Maybe at 15, we go here and look at this line maybe. So we have x1 plus h, and here we have y1 plus g. Let's see what this gives us. First we have to look for the value of y1 plus g, which is 22.5, and x1 plus h is 15. So we have m equals 22.5 minus 10 divided by 15 minus 10, which gives us 12.5 divided by 5, which is 2.5. So we see we get closer and closer to this value of 2. So what we try to do is to make this triangle smaller and smaller. So let's say we want to have it at point a equals 10 for x, we can write the derivative of a, which is 10, equals the limit, if h goes to 0, of f a plus h minus f of a divided by h. H is the value we add to x1. For instance, here it would be 10, here it would be 5, and so on. So plug in the value of 10, we have the limit h goes to 0, f of 10 plus h minus f of 10 divided by h. So we know f of x equals x squared divided by 10. So we have to find the values for this a equals 10, which is 10 plus h squared divided by 10 minus 100 divided by 10 divided by h. So let's continue. So we have 100 plus 20h plus h squared minus 10. This is also divided by 10, and everything is divided by h. This gives us 10 plus 2h plus h squared divided by 10 minus 10, and everything divided by h again, which is, this cancels out, so we have 2h divided by h, this cancels out, plus h squared divided by 10 times h, so this cancels out again, and so we end up with limit of h goes towards 0 of 2 plus h divided by 10, which gives us h goes to 0, 2, which is the correct slope. So in general, the derivative of a function of a real variable measures the sensitivity to change of the output value of a function with respect to change in its input value. And it also gives us the slope, so it exists. And maybe another note, taking a derivative is also called differentiation, and this is a very important tool in mathematics as well as economics and finance. So I hope you liked the video. If you have any questions, please say so in the comments. And if you have any questions, please say so in the comments. And thank you for watching.